All right, hello everyone. We're going to go ahead and get started with section 8.2, measures of area, volume, and capacity. So that's a review. We say since we live in a three-dimensional world, it's important that we're able to measure in 3 dimensions as well. It's also good to measure in 2 dimensions since we often only really need 2 measurements and we don't necessarily care about a third. So we're going to go over both of those things today, measuring in 2 dimensions and measuring in 3 dimensions. So on the side here, I have a dad joke. Dad is measuring up to his kid's ear. What are you doing? I'm measuring your patience. Nice. All right. So conversions of area in 2-dimension, 2D. We say units of length are called linear units since they're used to measure along a line. So units of size in 2-dimension are called square units since 1 square unit is the area of a square that is 1 unit long on each side. So the area of a figure is defined as the number of square units that fit inside of that object, and we use unit squared to indicate those square units in area. So whatever your unit is, centimeters, inches, feet, miles, anything like that, it will be squared. So we see we have our 1 square unit here, and our small square that's 1 by 1 by 1 by 1. So every side of it is exactly 1 inch. So this is the 1 square unit. Now in our box here, we have quite a few of these squares. Now we could count the boxes. We can say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we can count those, or we can multiply by the number of square units on each edge. So we have 5 along the bottom and 3 on the sides. Since it is 5 by 3 square units, we would assume that there would be enough of those boxes 5 times 3. So there would be 15 of those 1 square unit boxes that fit in that, depending on the length and the height, or the length and the width. So this would make it 18 inches squared. So conversions in 2D are often things like area and whatnot. So those are kind of the types of things we're going to look at. So these are conversions for area, which is 2 dimensions. So surface area, regular area, things like that. We have to convert measurements within the English unit system and the metric unit system sometimes. So we have some measurements here. So in our table, which we'll use throughout our section here, we have English conversions for area, and then we have English to metric conversions for area. So if you do have to use them, then that's what they are. But so for our English conversions for area, we have like 1 foot squared. So 1 square foot is equal to 144 inches squared. That's because there are 12 inches in 1 foot, but now we're talking about this square unit, these square units. So that would be broken up by a 12 by 12 inch box. 12 times 12 is 144. So we have those differences there. Then we have that 1 yard squared is equal to 9 feet squared, because there's 3 feet in 1 single yard. So a yard squared would be feet squared as well. If I get 3 times 3 is 9, which is also equal to 1,996 inches squared, using our conversion for 144 inches squared and 1 foot squared, converting that by 9. Then we have things like 1 mile squared is 27,878,400 feet squared. Also 3,097,600 yards squared. So we use our conversions to find these. 1 acre is 43,560 feet squared, and 1 mile squared is about 640 acres. Then one side note there, acre is already in a squared unit, so you don't necessarily write acres squared. It's inherently already squared. Acres are only measured in terms of area as opposed to miles, yards, feet, inches, those are just lengths. So acre is already measured in area. Then we have English to metric conversion. So we have 1 inch squared is about 6.45 centimeters squared. 1 foot squared is about 0.093 meters squared. 1 yard squared is about 0.836 meters squared. 1 mile squared is about 2.59 kilometers squared. And 1 acre is about 4,047 meters squared. So those are the different types of conversions that we can end up using when we do problems throughout this section. So how to convert measurements. We say below are the steps on how to convert one unit of measurement to another unit of measurement. In chemistry, this is called dimensional analysis. But here we're just using unit measurements, so just converting those. We use these steps for converting units of area and converting units of volume. So we'll get to units of volume in a little bit here. So we have steps for converting measurements. There are 4 steps. The very first step is to identify the unit that you're starting with and the one that you want. So we have a little example here off to the sides. We'll kind of read through this. We identify the unit. We have 55 centimeters, and what we want is meters. So we want to convert 55 centimeters to meters. We'll identify the relationship between those units. We say there's 100 centimeters in 1 meter, or same thing as saying 100 centimeters divided by 1 meter, or 1 meter is over 100 centimeters. These things are all equal. Then, once we've identified the relationships, we use the equality that we wrote. We were going to write 2 fractions. So whichever one will serve us the best, those are the ones we're going to use. Since we are starting with 55 centimeters, we want our next fraction to have centimeters in the denominator. So we take our original amount, we divide it over 1, so it makes multiplying all of this out a little easier. So we take our original amount, divide by 1, and whatever our unit was, that unit has to be in the denominator of the next fraction. This is because we will multiply in step 4, and when we do, those units need to cancel each other out. They need to go away, leaving the last unit that you want, which for us is in meters. So we'll take 55 centimeters and multiply by 1 meter over 100 centimeters. We multiply straight across, so we get 55 times 1 over 1 times 100, so 55 over 100. Now we only have meters. We canceled our centimeters, they were across from each other. This is also 0.55 meters. So those are the 4 steps that you take to convert your measurements. So take what you're starting out with, identify what you want, identify those relationships, express them as fractions, and multiply. Remember, when you're multiplying, those units that you don't want anymore, those need to be canceled out. So you need to be careful about where you're putting your fractions and in what order, because we always need them to cancel out diagonally when we multiply. So, all right, that's how we convert measurements. So let's take an example together. So we want to convert 3 square feet into square inches. We're going to use SQ as square, so we don't have to write square all the time. So we're converting 3 square feet into square inches. So number 1, we start with feet, and we want inches. We have 144 square inches is equal to 1 square foot, or coming up with our relationships here. We have that 144 square inches over 1 square foot, or 1 square foot over 144 square inches. These are all the different relationships. We need to pick the right one that we need. So step 3 is to set up your relationships. We take our original amount, the thing that we're converting, 3 square feet, divided by 1, and the other relationship we want, remember, we need to have our units cancel each other out. We want inches, so our inches should be in the numerator here on the second fraction. Square feet needs to be in the denominator, so they will cancel. These are our relationships. Step 4, multiply them together. So here we have 3 square feet over 1 times 144 square inches over 1 square foot. Those square feet will cancel each other out. We're left with those square inches, which is what we wanted. So we'll multiply and get 432 square inches. Multiplying across, we get 3 times 144 divided by 1 times 1. 1 times 1 is just 1. Anything divided by 1 is itself. So 3 times 144 is 432. And we're left with our square inches, which is what we wanted. So these are the steps that we need to take in order to convert measurements. Dimensional analysis, what we're doing here, converting our measurements, relies on canceling the measurement units that you do not want anymore so that you are left with the measurement units that you do want. So always be careful. You can come up with all the different relationships in step 2, but you need to identify which one you're actually going to use when you get to steps 3 and 4. And it will all depend on the unit. So, all right, there was our example there. Now we'll do an example all together. So we have an average of 2,191,781 square yards of carpet is discarded into landfills every day in the United States. How many acres will that carpet cover? So in this case, we're wanting to go from square yards into acres. We're going to use our conversions that we had a couple slides ago. We use those unit measurements and we'll multiply it out to convert into acres. So let's go ahead and do this all together. All right, so for example, we said that we needed to go from square yards into acres. If we go to our measurement, our unit measurement conversion table that we saw a couple slides ago, there is no direct conversion from yards into acres or square yards into acres. So we'll have to find a way to get there. Since that is happening, 2 ways that we can create our path to acres from square yards is that we can convert from yards to feet, and then we can convert from feet to acres. Or we can also go from yards to miles and miles to acres. You can choose which ones you want. So we can say yard to feet, then to acres, or yard to miles, then to acres. You can choose whichever one that you like, whichever one stands out more to you. That's the one you can go with. For us, we're going to go yard to feet and feet to acres. So this is the one that we are going to choose. So if we want to go yards to feet and then feet to acres, we need to make sure that that final unit ends in acres. Yards need to be canceled and feet need to be canceled as well. Square feet, square yards. So step 1 is always just identifying where we begin and where we want to end. So we know that we have yards squared. We need acres. So we know this, we know that we need acres. Step 2 is to find the relationships between the things that we want. We said we're going to choose yard to feet and then feet to acres. So those are the ones that we're going to end up using. We have that 9 feet squared is equal to 1 yard squared, which also allows us to say that 9 feet squared over 1 yard squared, or 1 yard squared over 9 feet squared. So we'll decide which one to use when necessary. We also have feet to acres. We know that there's going to be, let's see here, 43,560 feet squared in 1 acre. Meaning that our ratios here, our fractions, can be 43,560 feet squared over 1 acre, or 1 acre over 43,560 feet squared. So these are relationships. We're going from yards to feet and feet to acres. So we have all the different relationships between yards and feet and acres. So these are all the different relationships. Now we're going to go ahead and figure out which ones we're going to use. Step 3, we begin with what we currently have over 1. So for us, we currently have 2,191,781 square yards. So that's what we're starting with. We take that value, write it over 1. So we have 2,191,781. This is yards squared or square yards. And that's over 1. So it's the first unit we'll kind of start with. Then we want to go into our next value here. We have yards squared, and we said we're going from yard to feet and feet to acres. So to convert yards into feet, our next ratio needs to be a yard to feet ratio, and yard squared has to be in the denominator. We see that when we multiply them together, they need to be across each other so we can cancel, meaning that the ratio we'll want to use is this one, 9 feet squared over 1 yard squared. This will allow us to cancel out those yards. See how they're across from each other? That's what we want. Then we're not done yet, because this would result in feet. We want to go into acres as well. So same thing, we want to find the relationship between feet and acres, where feet squared has to cancel in the denominator of the next one. So looking at our ratios, that is the ratio we want to use. Feet squared is in the denominator of the next ratio. Acre is what is left in the numerator, and that is what we want to end with. So our last one here is 1 acre over 43,560 feet squared. And just like before, one more time, they are across from each other. Checks out. That's good. All right, so step 3. Step 3, figuring out the ratios we're actually going to use. And step 4 is to multiply them. So we're going to just repeat all of these ratios, but multiply. So we'll have 2,191,781 yards squared over 1 times 9 feet squared over 1 yard squared times 1 acre over 43,560 feet squared. So at this point, I always highly recommend canceling out the units now to make sure that you will result in the final units correctly. You will want to check here because you don't want to go through all of this work and then realize that your answer was wrong and you had to redo it anyway. So going through it now and making sure will ensure that you're going on the right path. So if we look here, yards is across from yard squared. We see that yard squared across from yard squared. They were across from each other, so they canceled. And we can do the same thing with feet. They are across from each other, feet squared. They are across from each other. Those cancel. The last thing that's left that doesn't cancel is the acre, which is what we want, which means that this will be the right answer. Now we get to multiply straight across. So we'll have 2,191,781 times 9 times 1 in the numerator. So 2,191,761,000 times 9 times 1 in the numerator there. And then we'll divide by 1 times 43,560. So this is what we're trying to find. This thing here, this is in acres. We can just barely fit that in here. Acres. This is in acres. So we can go ahead, we can plug all of this into a calculator. You can simplify a little bit more. You can multiply some of these out. Maybe you get, 19,726,029 over 43,560. This is acres. Either way, you plug it into your calculator, you're gonna round to the nearest, let's say 2 decimal places. This would come out to be about 452.85 acres. And that would be our answer. So we took that in quite a few steps, but remember we wanted to go from square yards into acres, which required 2 separate conversions. So identifying that we needed to go from yards squared into acres, so that require us to go from yard to feet or yard to miles, whichever one you decide. So yard to feet and then feet into acres. We're making those relationships, setting up the ratios, and multiplying them out in the correct order so we can get the correct answer. All right, that wraps up that example. Let's go on over back to the lecture. All right, so we had some measuring in 2D, conversions in 2D. So now we get to go on to conversions in 3D. So this would be conversions of volume and capacity. We see since 2-dimensional measurements are measured with square units, 3-dimensional measurements are measured with cubic units. So a square is the 2D version of a cube. We use unit cubed, unit to the power of 3, to indicate cubic units in volume. So whatever your unit is, centimeters, inches, feet, yards, miles, acres, whatever, you'll cube that value. So you'll have some value cubed. Acres would not be a value here since acres are only 2D measurements. But we do that, use our unit cubed here to indicate those volumes. We have a new part of these. So with our square inches, we just had the side lengths. We kind of had that area times width, or length times width is area. So that's how we ended up developing those different equations there for square units. In cubic units, we now have length times width times height. Those are 3 different measurements indicating 3-dimensional objects and cubing those units at the end. So measures of volume also include measures of what's called capacity, or the amount of fluid a container can hold. So we'll also move into kind of like fluid measurements as well. All right, so if we look at our single box here, this is a 12 by 12 by 12 inch box. We know that 12 inches is the same thing as saying 1 foot. So this is the same thing as saying 1 foot cubed. This is a 1 cubic foot. So we have these 12 inches here. We can multiply, we can find the value in terms of inches or in terms of feet here. Then we look over to the box next to it. We see this is definitely a much larger cube. It's made up of quite a few boxes. And when these are in feet, so we have our length and then times our width and times our height. So it'd be 3 times 3 times 3, which would be 27. You can count the boxes that you see here, although you don't see up the boxes, so it's not as efficient as a method of counting boxes. You get to multiply the sides. So 3 times 3 times 3 is 27. There'll be 27 of the little boxes, which remember indicate that 1 foot cube or 1 cubic foot. So we have different ways to like measure that volume. We see it comes 3D objects. This is more of what we see in regular life, 3D objects as opposed to 2D objects. We have conversions of volume as well as we did for like the 2D objects. So, and just like last time as well, sometimes we need to convert from English to metric, which we now just use as volume in general. So sometimes you have to convert sometimes not. It's entirely up to the problem. So we have all these different conversions here. First, we have our unit equivalencies for capacities in the English system. We have unit equivalencies for capacity in the metric system, and then units of capacity in the English system. So we have kind of some different things here. So this is more along the lines of like volume. This is more along the lines of capacity. And then they are very blended in the metric system. Metric is just volume. So starting with our units of equivalence or unit equivalences for capacity in the English system. So we have that 1 cubic foot would be about 7.48 gallons. 1 cubic yard is about 202 gallons. 1 gallon is about 231 inches cubed. And then we have water. We have fresh water and salt water. They're a little bit different. 1 foot cube or 1 cubic foot of fresh water would be about 62.5 pounds. 1 cubic foot of salt water would be about 64 pounds. That's because the salt content will make the water heavier in that case. So it is different between fresh and salt water. Then we have unit equivalences for capacity in the metric system. We have 1 centimeters cubed is 1 milliliter. 1 decimeter cubed is 1,000 centimeters cubed, which is 1 liter. 1 meter cubed is 1,000 decimeters cubed, which is 1 kiloliter. Then we say that 1 liter is about 1.06 quarts. The metric system is very clear. It works on basis of like powers of 10, so tens, hundreds, thousands. So everything is very nice. Whereas we see in the English system, it's not. So definitely very specific conversions for the English system for us. So we have units of capacity lastly in the English system. So just a couple extra ones here. We have 1 pint is 16 fluid ounces. 1 quart is 2 pints. 1 gallon is 4 quarts. So we have all these different measurements, metric and English system, that we can use to convert things of volume and capacity. So we'll do an example here together. How many gallons of Mountain Dew were in 1 2-liter bottle? So we'll start with liters. We want gallons. So we're saying we're asking how many gallons are in a 1 2-liter bottle. So we're starting with those liters. We're going to turn this into gallons. Just like our last example, there isn't no actual direct conversion for this. So we have to go from liters to quarts and then quarts to gallons. This is how we'll convert from liters to gallons here. So we have that 1 liter is about 1.06 quarts, and we know that there's 4 quarts in 1 gallon. So setting up those relationships, we have our original amount over 1, 2 liters over 1. Then we want to remember we're canceling our units. So our next relationship should have liters in the denominator. And so we have 1.06 quarts is over 1 liter. Then lastly, we use our relationship between gallons and quarts. We want to end with gallons. Quarts should be canceled, so it should be across. We have 1 gallon over 4 quarts. So these are the relationships that we'll use. We'll go ahead and multiply them in step 4. So we have 2 liters divided by 1 times 1.06 quarts divided by 1 liter times 1 gallon over 4 quarts. Just like before, we're going to go ahead and cancel our units to make sure we're going in the right direction. Liters cancel, quarts cancel, and we're left with gallons, which is what we want. We want to know how many gallons of Mountain Dew are in 1 2-liter bottle. So we're on the right track. Now we'll go ahead and multiply straight across. So 2 times 1.06 times 1 comes out to 2.12. And 1 times 1 times 4 would come out to 4. So we end up with 2.12 over 4 gallons, which, putting that in our calculators, gives us 0.53 gallons. So how many gallons of Mountain Dew are there in 1 2-liter bottle? 0.53 gallons. So just a little over a half gallon in one sitting. That'll be fun. All right. So now we'll do an example together again. So our last example here, we have the team managers for a college football team carry quart bottles of water for the players to drink during breaks for practice. The bottles are stored in carrying racks that weigh 6 pounds, and they each hold 16 bottles. If each bottle weighs a quarter of a pound when it's empty, how heavy is the rack when it's full in pounds? So there's quite a few things going on here. We're told that these team managers, they're carrying these quart bottles, the racks, 6 pounds, they hold 16 bottles each, and the bottles themselves are a fourth of a pound. So we need to be converting these quarts into pounds because we're carrying quarts of water in this case. We need to convert that into pounds so we can take that in addition to the racks, in addition to the weight of the bottles by themselves. So let's go ahead and do this together. All right, so for this question, we have another issue of there is no direct conversion between quarts and pounds. There's actually not even just one in the middle. There has to be two. We can go from quarts to gallons, and then gallons to feet cubed, and then feet cubed into pounds. So definitely there's going to be a couple conversions. So we'll write that out. We want to go from quarts into gallons, into feet cubed, into pounds. So this is the way that we're going to do this. Quarts to gallons, gallons to feet cubed, and then feet cubed to pounds. So when we go ahead and we add this all up, or we figure out our first step here, it's exactly what it is. This was really step one here, so we can just write that out. There we go. Will that be? All right, so step two. Step one, we're going from quarts to pounds. Now, step two, remember we want to establish, identify those relationships. So quarts to gallons first. We go to that table that we had there. We want to figure out that there are 4 quarts in 1 gallon. Then we have that there's going to be about 7.48 gallons in 1 foot cubed. Then we have gallons or feet cubed into pounds. And in this case, we're doing water. And we want to remember that there were 2 water amounts. There was fresh water and there was salt water. Salt water is not great to drink, especially quarts of them. So you want to use fresh water. So we want to use the measurement for the fresh water, which tells us that 1 foot cubed of fresh water should be about 62.5 pounds. So this takes us from quarts to pounds all the way through. Then step 3, we want to set up their ratios. One thing to know about these different types of ratios is that we're essentially saying that every one of these equations, both sides of them are equal. So technically, if you divided them out, they're really just equal to 1 because they're the same, they're equivalent. So since we have that type of statement, we can set up our ratios any way that we want between the 2 unit measurements. So we can have 4 quarts over 1 gallon, or we can have 1 gallon over 4 quarts. It doesn't matter because it still equals 1. So it doesn't matter which one is on the top and which one's on the bottom. It does matter when we want to cancel units. So when you're creating your ratios, you want to make sure that the units will cancel in your next ratio. That will determine which one goes in the numerator and which one goes in the denominator. So for step 3, we are starting with our quart bottles here. So we would have one single quart because that's how much the bottles hold, 1 quart of water. We want to measure the water first, then we'll take into consideration the weight of the racks and how much the bottle weighs themselves, because those are already in pounds, but we need to bring the water into pounds. So we're just focusing on the water in the bottles first. So we can say that for each single bottle, we're going to have 1 quart. So we'll begin with 1 quart, which means that quarts needs to cancel, making it so that your quarts to gallons ratio, quarts needs to be on the bottom. Because remember, we're going to start with 1 quart over 1. We start with our amount over 1. So our next ratio will be 1 gallon over 4 quarts. The same units should be diagonal from each other. Now for gallons, we have 7.48 gallons for 1 feet cubed. Same thing, gallon unit, and this one needs to be in the denominator. They need to be able to cancel. So we'll get 1 feet cubed over 7.48 gallons. Then last one, same thing, feet cubed needs to be canceled. So it would be in the denominator of the next term. 1 feet cubed divides 6.5 pounds. Like I said, just like last time, units should be across from each other. That means that that is correct. You'll be left with your pounds in the end. So step 4, we multiply. We've got 1 quarts over 1 times 1 gallon over 4 quarts times 1 foot cubed over 7.48 gallons times 62.5 pounds over 1 foot cubed. Just like every other time, we're going to go ahead, cancel our units. Quarts cancels, gallons cancel, feet cubed cancel, leaving us with pounds, which is where we wanted to go. So this pathway here is correct. Now we'll multiply straight across. In our numerator, we're going to have 1 times 1 times 1 times 62.5. So that one should be pretty clear. Then in the denominator, we have 1 times 4 times 7.48 times 1. And remember, this is going to be in pounds. So simplifying that down, plugging into our calculator, we should have 62.5 over 29, and we go 29.92, 4 times 7.48. This is in pounds. That went crazy there, in pounds. Plugging this into our calculator, and in this case, let's go ahead, let's just round to 1 decimal place. For this one, you can round to 2 if you'd like. It really will just depend on whatever your problem says. But we're going to go ahead, we're just going to round to 1 decimal place. This should give us about 2.1 pounds. So remember, this is for each bottle. So we have about 2.1 pounds per bottle. Now remember, our question was, if each bottle weighs 1/4 of a pound when empty, how heavy is the rack when the bottles are full? We now know how much each bottle weighs in pounds, so we can calculate how heavy that rack is going to be. So when we multiply this out, we're going to go ahead and figure out how much each bottle weighs. So bottle weight So finding our bottle weight in this case, we can go ahead and we can take the weight of our bottle with the water in it. So we said the weight of the bottle itself is 1/4 of a pound, and then plus the water makes it 2.1 pounds. So we can add those values to find the total amount of weight per bottle. So we can add those together. We have 2.1 for the weight of the bottle with water, and then we add on the weight of the bottle itself. We said the weight of the bottle itself was 1/4 of a pound. We already have decimals, so let's convert that 1/4 of a pound to decimal. That would be 0.25 pounds. And then there's 16 of them. So we multiply that by 16. So finding this value, 2.1 plus 0.25 will give us 21.35, which we can multiply by 16. And this should give us 37.6 pounds. So the weight of our bottles, of 16 bottles, is 37.6 pounds. So that bottle weight was for 16 of them. So all of our bottles are 37.6 pounds. And in addition to this, we have that each rack weighs 6 pounds itself. So when finding how heavy the rack is in total, when all the bottles are full, we take that bottle weight and we add 6. So that's how much the rack weighs as well. So we can find the total weight. This will be the rack plus the bottles. Will be 37.6 pounds of the bottles plus the 6 pounds of the rack, giving us our value of 43.6 pounds. And that's how much the total weight of the rack will be. So there was quite a bit of work that went into this. There were quite a few conversions. There was figuring out how much each weighed. So we wanted to convert the weight of our quart bottles filled with fresh water, convert that into pounds. So we had to figure out how many pounds each bottle was. Then we added on the bottle weight when empty. So how much just the bottle itself weighs. Multiply that by 16 for the 16 bottles that are on each rack. And then lastly, adding on that weight of the rack to get the total weight of the rack when all the bottles are filled, 43.6 pounds. So when deciding if you're going to be a team manager, you got to be able to push 43.6 pounds. So, all right. That wraps up that example. So let's go ahead and finish up our lecture. All right, that wraps up section 8.2. So in section 8.2, we learned how to convert units of area in the English system, how to convert measurements between English and metric units of area, converting measurements of volume in the English system, converting units of volume in the metric system, and converting measurements between English and the metric system in addition to capacity. So, all right, that finishes up section 8.2, and I'll see you in the next one.